Okay, question 4H3, Statistical Rethinking, second edition. So once again, make sure that you have installed and uploaded the Rethinking package with these two lines of code here. In the previous question, where were we here? 4H2. In 4H2, we built a model, and in the previous one, so we built a few models now with the HAL1 data set. And when we've done this, one thing that we've noticed in the data is that even though we're fitting this linear model, the data does not seem to be linear. Okay, and this was a feature in a few problems so far. Okay, we notice that that the data is kind of following this curve, so that the line kind of cuts above and below it at different weights of height. And so question 4H3 prompts us to try to fix this a little bit. So the idea is that somebody, maybe you or a colleague, says that height and weight aren't related linearly, but rather that that height is related to the log of weight. And so we decide to test this. Okay? And so that's what we'll do here. And if that is true, we should no longer need to partition the data for adults versus anybody, non-adult, children, and so on. So, so we have our data, and whereas in the past we were just using either adults or children, we're using the entire data set here, and we are going to use log weights instead. So previously we were using x bar, which was just the mean of weight, but now we're using the mean of the log weight because we're using log weights. Okay. Oops. And so here's our model. So notice that we are using the model that we've been using above, but we have now log weight minus log of x bar. Okay, that's really the only difference. Yeah. Okay, so now when we go to run this, we get our readout, our summary readout for the coefficients a, b, and sigma, alpha, beta, sigma. And now take a second and try to interpret what is being said here with this posterior distribution. It's not, well, it is somewhat straightforward. So it says that the average height is 138 centimeters. But then with B, it says that that for every 1 unit increase in weight, whatever the unit is, I think it's probably kilograms. But for every one unit increase in log weight, okay, then height goes up by 47 centimeters, right? So let me say that again. Because we are now regressing on log weight, the beta coefficient represents how height changes in response to a 1 unit increase in log weight. And if you are like me, it's not easy to think in terms of logarithms, in this case, log weight. And so we're going to take these numbers and we're going to try to put it on the raw scale rather than on the log scale. Okay, so this is code that I just copied from above. Importantly, I really copied it from above. Okay, so so in other words, so I have weight seek, and you'll notice that this is just numbers, just like we had above, that go from 0 to the max weight of our sample, even though our model was written in terms of log weights. Okay, so all I've done is I've taken the weight, I've just put it on this scale, on the raw scale. Okay, I've also created this new variable here that I'm calling log weight seek, because we're also going to plot it on the logarithmic scale, just to highlight a couple of things. So let me run these plots here. Okay, so here's the first plot. Okay, so this is putting everything on the raw scale. Okay, so we have height on the y-axis and weight on the raw scale on the x-axis. What do we have there? Okay. And so we see something interesting. So even though the model was linear, because we regressed on the logarithm of weight, when we back that out to the raw scale again, our linear model becomes nonlinear, and it seems to fit the data pretty well. You can still see that there might be some bias here, but anyway, it does a pretty decent job. And there's also a problem that we saw in the last question, which is that the variance, so the model assumes one value for sigma, right? That it's trying to estimate, but we see that sigma, or that the variance around the mean seems to be increasing with increasing weight. Okay, I'm just noting that for right now. Okay, so now let's see what these look like when we go to the log scale for weight. Okay, so now we're on the log scale for weight. Okay, and you see that now now log scale, log scale for weight on the x-axis. Now the relationship that was curvilinear up here, just by changing the scale, is now linear. And again, we see a fairly decent fit. And one thing to notice is that the problem that we had with the standard deviation, or the variance, getting increased as we went up in weight, it still seems to be there, but not as bad. Okay, so the variance around the mean seems a little bit more consistent as we move up in log weight. Okay, that's it.